If you're a mechanical engineer, you know the struggle of working on a weak laptop. Not only does it reduce your productivity, but it also increases the risk of crashes and potential long-term workflow issues. So, before you buy a laptop for mechanical engineering, here are the minimum specifications we recommend. Starting with the processor, you need strong single-core performance, ideally 3 GHz or higher. Most CAD software relies heavily on single-threaded performance for geometric calculations, viewport manipulation, and command responsiveness. While multiple cores help with multitasking, they don't significantly accelerate 2D and 3D design tasks. In simple terms, a 4-core CPU running at 4 GHz can outperform a 10-core CPU running at 2.5 GHz for CAD work. With that in mind, aim for at least a 12th Gen Intel Core i7 or an AMD Ryzen 7 5000 series processor. If possible, look for newer chips with dedicated NPUs or neural processing units to support AI-driven generative design tools and future-proof your system. For heavier simulations, consider stepping up to an Ultra 9 processors. Next is the graphics card, GPU. A dedicated GPU is essential for 3D modeling, simulations, and rendering tasks. You should look for at least 6 GB of dedicated video RAM, starting from an NVIDIA RTX 4060 or equivalent. For more complex rendering and simulations, aim for an RTX 5070 or higher with 12 GB or more video RAM. While GeForce cards like the RTX 5070 or 5080 offer strong performance for the price, RTX professional GPUs, formerly Quadro, are preferred for ISV certification, which ensures better stability and access to specialized features such as order-independent transparency in software like SolidWorks. Next is RAM. If you're a student, 16 GB is workable, just make sure the laptop is upgradable. For professionals, 32 GB of DDR5 RAM is becoming the new safe minimum. In 2026, 16 GB can quickly become a bottleneck when running simulations alongside multiple browser tabs and communication tools. For storage, always choose an NVMe SSD. It's significantly faster and smoother when launching applications compared to SATA SSDs or HDDs. Most modern laptops already use NVMe drives, so this shouldn't be an issue. However, additional SATA or HDD storage can still be used as a secondary internal storage in addition to your NVMe SSD. In terms of capacity, aim for at least 1 TB, since a Windows installation plus software like SolidWorks and AutoCAD can easily take up around 200 GB. For the display, go for at least a 15-inch color-accurate panel. As an engineer, you're not just viewing simple lines, you're analyzing stress maps, simulations, and realistic renders. A display with 100% sRGB or high DCI P3 coverage ensures that what you see on screen accurately reflects the final output. You also have to make sure it has a good brightness for outdoor use. Make sure the laptop has a minimum 400 nits of brightness. Last but not least is thermal management. Engineering workloads put sustained pressure on your hardware. Avoid ultra-thin laptops unless they have exceptional cooling solutions like vapor chambers. A thermal-throttled i9 will often perform worse than a well-cooled i7. With these requirements in mind, we've compiled a list of the best laptops for mechanical engineers in 2026. The list includes both budget-friendly options and high-end workstation laptops. We've also included links to each model in the description below, so be sure to check them out for current pricing and availability. Without further ado, let's dive into the list. First on our list is the Acer Nitro V16S. If you're a student or on a budget and need a laptop that meets the needs for a mechanical engineering workflow, this is an excellent entry-level option. It features metal top and bottom covers, providing better structural rigidity and making it more suitable for occasional outdoor use. Opening the lid, you're greeted by a 16-inch WUXGA display, a modern, vertically spacious screen built on an IPS panel with 180 Hz refresh rate. It also offers 100% of sRGB color coverage and up to 400 nits of brightness, which improves visibility and usability in brighter environments. Now, looking at the core hardware, the laptop is powered by an Intel Core 7 240H processor with a maximum turbo frequency of 5.2 GHz. This makes it well-suited for CAD applications in SolidWorks, where strong single-core performance is critical. The processor also features 10 cores, including 6 high-performance cores, which is beneficial for workloads like finite element analysis in ANSYS or thermal simulations, where both clock speed and core count matter. Paired with the CPU is an NVIDIA RTX 5060 GPU with 8 GB of GDDR7 dedicated video RAM. This configuration can comfortably handle complex assemblies in software like SolidWorks, Autodesk Inventor, and CATIA. In terms of memory, the laptop comes with 16 GB of upgradable DDR5 RAM along with a fast 1 TB of NVMe SSD for storage. At around $1,200 at the time of making this video, this laptop offers strong value for money and outperforms much of the competition in this price range for mechanical engineering tasks. However, there are a few drawbacks to consider. The base 16 GB of RAM may become limiting for heavier workflows, so you might need to upgrade it. The cooling system can also get loud under load due to the compact design, and battery life is relatively short, especially during CAD work, where you can expect around 3 hours at most, which is common in gaming laptops. This also means you'll likely need to keep your charger with you. Next up is the Asus ROG G16. For the mechanical engineer who needs elite-level performance in a travel-friendly package, this is a top-tier option. Despite housing an NVIDIA GeForce RTX 5070, it weighs under 2 kilograms. The CNC machined aluminum unibody looks professional while ensuring excellent portability for the engineer on the go. Opening the lid, you're treated to a gorgeous 16-inch 2.5K ROG Nebula OLED display with a blistering 240 Hz refresh rate. With a whopping 1,100 nits of brightness and 100% DCI 3P color coverage, this panel is built for HDR content and helps maintain visibility in any environment, from bright offices to outdoor fieldwork in direct sunlight. Under the hood, it's powered by the latest Intel Core Ultra 9 285H processor with a maximum turbo frequency of 5.4 GHz, paired with 32 GB of LPDDR5X memory. The laptop comes in multiple RAM configurations, ranging from 16 to 32 GB. However, the memory is soldered, meaning it cannot be upgraded later, so you'll need to choose the right configuration at the time of purchase. For storage, you get a fast 1 TB of NVMe SSD. Complementing the CPU is an NVIDIA RTX 5070 GPU with an impressive 12 GB of dedicated video RAM, delivering excellent single and multi-core performance. This makes it highly capable for demanding CAD applications like SolidWorks and CATIA, as well as simulation workloads in ANSYS. The integrated NPU also enhances AI-related tasks, helping accelerate workflows such as real-time rendering in Lumion and AI-driven generative design. Starting at around $2,500, the Asus ROG G16 is a premium investment that delivers top-tier performance and build quality. However, there are a few things to keep in mind. While the cooling system is improved and relatively quiet under moderate loads, it can still get loud during sustained heavy workloads, as this is a compact machine pushing high-performance components. Again, the soldered LPDDR5X RAM means there's no option for future upgrades, so choosing the right configuration up front is essential. Next on our list is the Razer Blade 16. For the mechanical engineer who refuses to compromise on portability without sacrificing elite workstation-class performance, this is arguably the pinnacle of mobile engineering. The brand has carved its chassis from a single block of aerospace-grade T6 aluminum, resulting in a stunning minimalist shell that weighs just 4.71 pounds or 2.14 kilograms and is an incredible 14.9 millimeters thin. Opening the lid, you're treated to a breathtaking 16-inch QHD+ OLED panel. This professional-grade display has a 2560 by 1600 resolution with a 240 Hz refresh rate and achieves a massive peak brightness of 1100 nits in HDR mode. It's also factory calibrated, which means the colors are already tuned to be very accurate right out of the box. With full DCI 3P color coverage, it can display a wider range of colors than standard screens, making it great for tasks like design work, rendering, and reviewing visuals without needing an external monitor. Under the hood, this laptop is powered by Intel's new 16-core Core Ultra 9 386H processor with a maximum turbo frequency of 4.9 GHz. This chip offers a 33% increase in core count over its predecessor, which directly benefits heavily multi-threaded workflows like finite element analysis in ANSYS or running complex CFD simulations with zero lag. Paired with the CPU is the top-spec NVIDIA RTX 5080 with a whopping 16 GB of GDDR7 video RAM. The system channels data through 32 GB of ultra-fast LPDDR5X memory, allowing you to spin massive 3D assemblies in SolidWorks or simulate complex fluid dynamics models with zero lag. At a starting price of $3,500, this laptop is positioned as a premium solution, but it delivers a combination of build quality, display technology, and raw computational power that is truly rare to find. However, there are significant trade-offs to consider. The most critical limitation is that the fast LPDDR5X memory is soldered directly to the motherboard, meaning you cannot upgrade your RAM after purchase. The 32GB you choose today is all the system will ever have. Like all ultra-slim workstations, the fans can also get quite audible during sustained simulation loads, and while Razer promises a massive leap to 13 hours for general productivity, you should expect standard short battery life for this class when pushing the RTX 5080 during intense rendering or analysis tasks. Next on our list is the Lenovo ThinkPad P1 Gen 8. If you're a mechanical engineer who needs an uncompromised mobile workstation that feels as good as it performs, this is one of the strongest options available. The build quality is great. The chassis is constructed from recycled aluminum and magnesium, delivering a phenomenally rigid, military-grade shell that absorbs shocks from fieldwork or daily travel while weighing an astonishing 1.84 kilograms, lighter than a MacBook Pro 16, making it the lightest option on this list. Opening the lid, you're greeted by an exceptional 16-inch 3.2K tandem OLED display. This technology stacks two OLED layers for heightened brightness and longevity, achieving 600 nits in SDR and a massive 1500 nits peak in HDR. With 100% DCI P3 coverage, Dolby Vision, and VESA Display HDR 600 certification, it's ideal for design reviews where color accuracy and visibility under harsh office lighting or outdoors are critical. A smooth 120Hz refresh rate and an anti-glare, anti-smudge coating further improve usability for long working hours. Under the hood, this laptop runs on the Intel Core Ultra 9 285H, boosting up to 5.4 GHz with 16 cores. That means fast performance for CAD work in SolidWorks and strong multi-core power for simulations. Paired with the CPU is the NVIDIA RTX Pro 2000 Blackwell GPU with 8 GB of GDDR7 video RAM and full ISV certification for applications like CATIA, ANSYS, and Autodesk Inventor, giving you better stability than typical GPUs. You also get 64 GB of LPDDR5X RAM in dual channel, using the new CAM2 design. Unlike most thin laptops, this RAM isn't permanently fixed. You can upgrade or replace it later, which is a big advantage for handling larger projects over time. A 2TB PCIe 5.0 SSD provides lightning-fast storage, with a second empty M.2 slot available for future expansion. With this top-tier configuration typically priced around $5,200, the ThinkPad P1 Gen 8 positions itself as a premium professional-grade tool that reflects its ISV-validated engineering and unique upgradability. That said, there are a few trade-offs. Battery life is decent for light work, around 10 to 12 hours, but heavy simulations will drain it much faster. The cooling system works well, but the fans do get loud under full load. Also, the 8GB video RAM on the GPU might feel limiting for very large or future simulation workloads. Finally, we have the Dell Pro Max 18 Plus. When your simulations outgrow every other laptop and you refuse to be tied to a desk, this is the only logical answer. This mobile workstation is in a class of its own, featuring a massive 18-inch display and a chassis that prioritizes cooling and performance above all else. That 18-inch panel is a high-resolution 2.5K IPS display, providing incredible screen real estate for managing complex assembly trees in CATIA or monitoring multi-physics simulation runs side by side. Under the hood, it's nothing short of monstrous, an Intel Core Ultra 9 285HX with 24 cores and a maximum turbo frequency of 5.5 GHz, paired with an NVIDIA RTX 5000 Pro with a whopping 24 GB of video RAM. For storage, it packs a massive 64 GB of CAM2 RAM. This makes it capable of running entire vehicle crash simulations, massive CFD models in OpenFOAM, or complex multi-physics simulations in COMSOL entirely in memory. It has a 2TB of storage and also supports up to 8TB of high-speed NVMe SSD storage. This is an enterprise-class machine with a price to match. Expect to invest around $7,000 or significantly more depending on the configuration. Dell also offer multiple configuration options for this laptop, with an option to personally configure and purchase the kind of spec you want. But there are some clear downsides. First, it's heavy, at about 3.25 kilograms, so it's not something you'll want to carry every day. Second, battery life under heavy workloads is only around 5 to 7 hours, so you'll often need to stay plugged in. And finally, like any high-performance machine, it gets loud when pushed to its limits. There you have it, our top 5 pick for the best laptops for mechanical engineers in 2026. If you found this video helpful, give it a like and subscribe. Thank you for watching. We'll see you in the next one.